Hello, my fabulous chemistry students. Video number 3. Let's wrap up this ionic versus covalent stuff. And today what we're going to do is we're going to look at the different properties that we have. And we'll eventually be able to determine whether a substance is ionic or covalent based on the physical properties that are different, much like how the metals and the nonmetals had a different kind of properties, and we studied that in the lab. We're actually going to be able to do a very similar kind of lab with an ionic and a covalent compound. So what is basically the difference between an ionic and covalently bonded compound is the question. And these two pictures do a pretty good job of showing us. So I'm just going to walk us through. Let's start on the picture on the left. Okay, I have, it looks like two helium atoms because I have a proton and electron each. And you'll see that as they when they bond, they are going to share these two electrons. So each technically has two, just like it wants, but they're going to share them. Okay. Now this other side, I have this given up an electron to the other side altogether, and then this is going to become negative. This is going to become positive, and the two are going to stick together like magnets. But now all the electrons are on this side. They are no longer sharing. That atom has all the electrons itself. So we call that ionic bonding when I'm making with ions, and a molecule when I'm using atoms that are sharing electrons. So we're going to fill out this chart so we'll know exactly the difference between the two. I'm going to start on the left-hand side with ionic, where the electrons are completely transferred. So you'll see this X is going to jump over here, form a plus and a minus, and that's how Na and Cl are going to bond. The physical properties of all ionic solids we're going to find, and we need to memorize these. They're going to have very high melting points and boiling points due to the strength of their bonds. The melting point is one that we will be able to test. Normally, I can't get anything high enough in temperature to actually boil a liquid ionic compound. All right, electrolyte means just what it kind of sounds like. It starts with electro. Okay, so if I take that powder and I put it into solution and dissolve it, it is going to dissociate and conduct electricity. Ionic compounds are also generally very hard. They're kind of brittle. They will shatter. Electronegativity differences. You're going to hear me refer to this as END, electronegativity difference. Okay, it has to equals 2.3 for this particular case. I look up chlorine's electronegativity is 3.2, subtract 0.9, which is the electronegativity of sodium, and I come up with 2.3. Basically, anything that is greater than 1.4, you'll need to make a special note there. If it's greater than 1.4, it is ionic. So an END greater than 1.4. Now on to covalence. Here, our electrons are shared. Okay. Physical properties, just like with the metals and nonmetals, they are going to be basically opposite. I'm going to have a low a low melting point and boiling point due to the weak intermolecular forces. Okay, it is a non-electrolyte, so it's not going to conduct electricity, and it is also soft. Okay, so electronegativity difference, again, END. If I take 3.5, and I'm just going to subtract it from one hydrogen, not both, 2.1, I get 1.4. Okay, and to be ionic, I have to be greater than 1.4, so less than or equal to 1.4 is covalent. As far as our bonding, we can tell that way. Okay, we can always calculate END if we need. So basically, the greater the electronegativity difference, the greater the percent that it's going to be ionic. Okay, and the ionic character, more like just like metallic character. The closer I get up into that 1.4 and past, the more ionic I'm going to be. The closer the electronegativities are together, of course, I'll have more covalent character. Let's see. Metal, non-metal is the trump. That's the easiest way we learned in slide 2. An ionic compound is a metal and a non-metal. If it's two metals, it's covalent. Okay, and then if we still don't know, we're having trouble figuring out what the elements are, we can always refer to the END, electronegativity difference. Okay, and the greater it is, the more ionic, and the less it is, the more covalent. Remember, this has got to be greater than 1.4, and to be covalent, I need to be less than or equal to 1.4. 1.4 is that magic number I need you to know. So let's do a little bit of practice, and I'll walk you through a few, and then I'll leave the rest for you to do. Let's do CaO. A handy dandy reference table. I look up calcium, and I see calcium has an electronegativity of 1.0. And oxygen has an electronegativity of 3.4. So I'm going to take 3.4 minus 1.0, and that equals 2.4. And so where does that fall? Is that less than 1.4 or greater than 1.4? It is greater than 1.4, so it is ionic. Okay. Skip down to iron chloride, FeCl3. More handy dandy reference tables. I'm looking for iron. I see iron. Iron has an electronegativity of 1.8. Chlorine has an electronegativity of 3.2. I'm going to just subtract the smaller one from the bigger one because I don't want a negative number. 3.2 minus 1.8 is 1.4. Ooh, that's tough. It's 1.4. So this is, according to this, 1.4 and less should be covalent, right? Now let's look at our species. What is iron? Is that a metal or a non-metal? It's a metal. And chlorine is a non-metal. So if I have a metal and a non-metal, I should be ionic. So this indicator here is, the math is always, of course, not the best. Metal, non-metal is our trump card, okay? So just remember that, metal, non-metal. You guys do the rest of these. I got the hard ones out of the way. And now we can identify a sample based on its physical properties. Does it have, what's its melting point? What does it, is it hard? Does it conduct electricity? Conducting electricity is, pretty, it's another telltale sign, if you will. Ionic is going to have a large difference in END, and covalent is going to have a smaller one. If they're right on the cusp of that 1.4, make sure we go back and check, is it metal, non-metal? So that's it for today. I'll see you guys tomorrow in class.